Hello everyone and welcome to another video. Today I will be solving the examples that I posted to Flatside in one of my videos from, as a matter of fact, over 2 months ago now. Now I asked these questions to Flatside. Let's quickly let past Olaf go through them. The big explainer, the big brain in the field of thermodynamics. Some 3 very easy exercises. Here is problem 1. I will quickly read you through it. We got that in the first week when we started our thermodynamics course, so it's really easy, really basic. The second one here is which one of the 2 statements, these 2, violates thermodynamic principles, if any. Could be none. Especially regarding entropy, because you know what this S is here? This S here is entropy. Well, would you believe it or not? This is taken from the Kalen book, by the way. And the problem 3, my favorite exercise here. By the way, we got that one in the second week of the thermodynamics course, and we got that one in the third week, which is which of the 3 equations, find the 3 equations of state in the entropy representation for a system with the fundamental equation. Here's the fundamental equation. And do you see this S here, the small s? That's the intensive entropy. So I doubt that you know what an equation is. Exactly, I skipped over the first one there by accident. The first one is this one. It's a bit more easy. It doesn't really even have anything to do with entropy. It's just basic. I have issues even calling it thermodynamics. That's almost gas laws applied, right? And I have asked Flatside a couple of times ever since. One time in his live chat where he reacted to it. Where I asked him about the exams, the examples, if he had done any or tried any for that matter.
Conjunction that opens this sentence is a valve conjunction.
Olaf says, I thought I asked their examples. Those 3 examples, I haven't even looked at them again. But to be honest, I don't know if I'm going to be able to do it because you know me and maths. But I said I will try and do it, Olaf. But thanks, mate.
Yeah, so I'm unsure if that's genuine, if that's just a hand wave dismissal, but I honestly don't really care. So why not have a look at the examples? So here we are back at my OneNote drawing board, and I will now go through the examples and tell you why some of them violate principles of entropy and why the others don't. So for this first example here, I asked him which of these 2 equations are not agreeing with the fundamental equations of various thermodynamic systems, right? So which of these disagree, right? 5, it says here 5 are inconsistent. I gave him those 2 and said both could be, none could be, 1 could be. So there are a couple of basic fundamental kind of properties of entropy with the so-called postulates of entropy. One of them is that entropy is homogeneous to the first order, if you must know. So if you have the entropy, and it depends on a factor a, b, and c, and you multiply the factor a, b, and c by a constant that is lambda, it has to be lambda times the entropy of just the normal ones, without this multiplication factor of lambda. So when we do this for I didn't do it for case A, I'm now just doing it for case B, because case A is actually fine. You can see that, well, first of all, V0, this Greek letter here, and R squared are constants, so they are not so the entropy doesn't depend on them. Entropy depends on this N, this V, and this U. So you would multiply lambda here, here, and here, so that's 3 lambda, so you have lambda to the 3rd, and then you get the 3rd root from that, so that's lambda, so that the first one checks out. But for the second one, we run into a problem. When you add a lambda here, and a lambda downstairs here, you get lambda squared over lambda, and you get you exponentiate that by 2/3, then you get lambda 2/3, which is not lambda, of course. So B is not valid, not a valid form of entropy at all. So that's the first example, and again, I would like to emphasize, we got these exercises within the first 3 weeks of our thermodynamics course that lasted a whole semester, and the beginning was very easy. The first round of exercises we got even before having any lectures, just as a couple of reminders. So these are things that you can learn in 2 to 3 weeks. None of these are hard, and if Flatside Flatzoid claims that he can debunk established thermodynamics, and he can't. Well, first of all, he said he doesn't have the math on trying to solve all of these, which I'll let it speak for itself. But if he can't solve any of these, he really has no business talking anything about thermodynamics whatsoever, because he clearly doesn't understand it. Second example here, that's the more difficult one of the three, which is find the three equations of state in the entropy representation for the system with the fundamental equation. This here and this S squared here is the intensive entropy. So first I rearrange for S, which gives me this result here. And now from the lecture, or from the Kalem book, if you want, you get various identities. For example, the derivation of the entropy over the heat energy, or sometimes just called heat, is equal to 1 over T if you leave the V just as it is, kind of. Just if you pretend that the V isn't a quantity that the entropy depends upon, right? And so you get several results. For example, here you get T is equal to this one. You do the same thing with other identities, where you get P, which actually boils down to just that. And you can do the same thing for this mu here. Mu in this case is chemical potential, which is then this one. It's a bit more calculation work, but nothing of this should be difficult, although you do need to know how to derive, although none of the derivations here are difficult. They are well within the realms of what you do in school in Austria. Third example was the easiest of the bunch, at least for me. I remember when I did them it was. So you have the main, you have a thermodynamic diagram here, if you want. This is what could be called a work diagram sometimes. So you have this right here, where you have a couple of points, 4 points, and I added the fifth one in. And you should calculate the energy of the state F, where PF is this one, and VF, the volume of F, is this one. And when we know that UA is equal to 0, so the heat energy at A, we set to 0, and we should suppose that the walls are adiabatic, and the volume is observed to result in a pressure increase and decrease with the equation of this one. So the first thing we do is you actually you can play a little trick here. You don't actually need this equation, although you can use it. You first get the pressure here, because it tells you the pressure of D and B, so you can calculate the pressure F, and you can just read off the volume F. And from that, you can insert some basic heat equations. That just means that the change in heat energy is equal to 3 halves times the volume times the change in pressure. And you can insert all of that right here, where you treat this kind of differential du here just as a literal difference between 2 points with that. And when you know what the UB is, because you actually need UB here, you can go to this path. You go from A to B. That's the first thing you calculate, and then you go up to F. And that's the only thing that you need to do. Then you get how much energy you win from B to F, and then you just need to subtract the UB, and then you land at that many joules. I didn't write joule on here. Of course, it should be joules. Yeah, so that one's also really quick. That takes like 10 minutes to think about. This one takes like 15 minutes for the maths, and this takes like, to write it down, it takes 5 minutes, but you can literally look at it in the equation. This can take less than a minute. Yeah, so the fact that Flatzoid, well, first of all, didn't really properly attempt any of them, probably because he knows exactly well that he can't do them, which is unsurprising, because his understanding of entropy can fit on a stamp. But other than that, I think I have once again conclusively shown that Flatzoid has absolutely no fucking clue about entropy whatsoever, and that he probably should stop talking about gas physics. There is another very funny thing he said that I will make a video about when it comes to vacuum. But yeah, I hope you did enjoy this little video, and I will see you in the next one. If you enjoyed it, please consider leaving a like. If you enjoyed it a lot, maybe considering subscribing. And yeah, until then, have a nice week. Goodbye.